Hello and welcome back to Triplicate, home of interesting electronics. And today we're going to move on with the radio controlled lorry project, where we're trying to use the trusty Arduino to make it a bit easier to drive and a bit more realistic in the way it behaves. So at the end of last video I promised to spend some money to buy some bits, and here they are. We have a ribbon cable to connect the existing electronics in the cab to the new electronics in the trailer. We have, well, the Arduino, which we had anyway. We have a development shield to go on top of it. We have some connectors for the ribbon cable. We have two different types of H-bridge motor driver board, more of them later, and we have a battery box so we can mount 4 more batteries in the trailer in addition to the 4 that live underneath the truck. Now, if you remember the last video, I said we would need something to measure the wheel speed, some sort of sensor, and some sort of method of measuring the steering position. You can't see that, can you? I'll take the cab off. There you go. There we go. And you will notice in all my bits and pieces I haven't got anything to do either of those jobs. And the reason I haven't, well, to explain that I shall need to go into a bit of theory on how electric motors work. Okay, so here we have the basic equation for the volts across the motor. I don't propose to go into the electromagnetic theory behind these equations. I'm just going to give you the equations. There's a couple of links in the description to websites that do go into the more detail, and you're welcome to have a look at them if you want to. So what we have here in this equation is VO is the power supply volts. That's the volts across the motor. I is the current through the motor. R is the resistor of the motor windings. And VE is the back EMF. Now, every time you spin an electric motor you get a back EMF. If you spin it from an external source, that's the voltage. The motor acts as a vent generator, and that's the voltage you get out. Whereas if you're actually spinning it from a battery or something, you effectively get the same voltage, VE. Now, VE is given by the simple equation S times Ke, where S is the motor speed. Note that one, that's the one we want, and Ke is just a number, a constant, which depends on the motor. So we can rearrange these two equations and get VO equals I times R plus S times Ke. And again, then we can rearrange that to get the speed S is VO minus IR, all divided by Ke. So if we know the volts and the current in our motor, we can calculate the speed from that equation. Now, R we can either measure or find by stalling the motor, so S is 0, and Ke, once we know VOI and R, and assuming we can measure S at some point, we can calculate Ke, so we've got everything we need to know. So what about the torque of the motor? Well, that is simply given by T equals I times Km, where T is the torque developed by the motor, and I is the current through the motor, and Km is the motor torque constant. Again, just a number which we can calculate or guess or whatever. And why do we want to know the torque output from the motor? Well, you will see sort of in the picture that there is a spring which pulls the wheels back to the straight position. Now it's a property of a spring that the further you move it, the more force you require, and that's a linear relationship. So if we can put a known amount of torque into this motor, we can set the wheels to a known turn, so we can control accurately, we hope, the steering of the truck. Okay, so let us decide what we're wiring to where and draw out a circuit of some sort. So I guess at this point we need to make a decision as to which motor driver board we're using. Right, so this one uses an L298N, which is this lump on a big heatsink, which is encouraging, and I already have a data sheet for that, and there is also a data sheet for this board telling you how it's all wired up and what to connect to where and what the jumpers do. Whereas this little guy uses an MX1608 chip, and looking on the net there are lots of people saying, does anybody know where to get a data sheet for it? But there is no data sheet available for it. So sadly for our Chinese friends, I think this one is not going to do the job we want. So let us move on using this motor driver board. So our motor driver is what's called an H-bridge driver, and here's a very much simplified version of what it's doing. So you can see why it's called an H. The motor and the four switches form the shape of an H. So if we close switch 1 and switch 4, current's going left to right through the motor, call that forwards, and if we close S2 and S3, current is going left through the motor, call that reverse. And we control these switches by PWM, so we can control the amount of power that's going through the motor. So the L298 contains two motor drivers, which is convenient for us because we've got two motors we want to control. And this is from the data sheet. It's a picture of how one of them works. So pins 10 and 12, C and D, you put your PWM on there, and the table shows how you do that to get forward and reverse. So C is high and D is low forward, C is low, D and high reverse, C equals D means the motor is basically the motor is shorted together, so it'll stop quickly because you're putting a lot of current round the windings. We won't worry about that. And V is the enable, so if we put the enable low, then both outputs go high impedance, and the motor is effectively disconnected. Another thing to note is the four diodes D1, D2, D3 and D4. This is because when you disconnect the current from a motor, which is essentially a big inductor, you'll get a back EMF which can damage the electronics, and the diodes just soak that up. the same setup as you have when you put a diode across a relay. And finally, at the bottom here, we have RS, the sense resistor for the current, which is something we're interested in. The current simply goes from the motor, goes through that to ground, and we just measure the voltage across that resistor and calculate that current from Ohm's law. Okay, and here's the circuit for the big rig. Okay, on the right here we have the connector for the ribbon controller. The top 8 are the left hand side are the connections to the drive chip, which normally goes straight to the motor, and the two motors are on the right hand side. So to run it as it was designed, 1 is connected to 2, 2 is connected to 3 is connected to 4, 5 is connected to 6, and 7 is connected to 8. Because those inputs from that chip may creep over 5 volts, we need to protect them with 4 47Ks, because if we look at the input I/O for the 80 mega, the inputs are protected by diodes, but we do need to limit the current through those diodes. On the other side, the motor driver, should we look at the motor driver board? That's the motor driver board schematic. So simply the inputs there, the outputs there. The enables we're not using at the minute. It has its own 5-volt regulator, which is useful. Now the current sense is shorted to ground. Pin 15 is actually shorted to ground. The schematic's wrong. So I've had to modify the board to access those, which I'll show you in a minute. And because we're driving the motors with PWM, the current sense resistors, the voltage across those will be shooting all over the place, so I've smoothed those quite drastically. And we want to know the voltage, the supply voltage, because that will go up and down with battery charge and load. So that's measured. Those two resistors drop that down to a suitable level for the A to D, and we smooth it because that'll bounce about as well. Lastly, we've got a battery here. That's actually 4 batteries providing another nominal 6 volts. It'll be nearer 5 because I'm going to use rechargeables, and that is the 6 volt coming in from the 4 batteries which live under the cab. And that is about that. So shall we go and have a look at what I've done? Okay, so this is what we've got. Firstly, we have the connection to the ribbon cable, and this will somehow mount in the back of the cab here, and the ribbon cable will go through into the trailer, which is over there, and in the trailer we will have this little lot. So we have the Arduino under the bottom there with the shield connected to it, which for reasons I will explain isn't connected, and look at this. The Arduino is powered from the 12 volt supply, the main 12 volt supply. Okay, this is the driver board, the motor driver board, and this is the battery holder for the 4 extra batteries. Okay, so let's see if I can hold the camera steady enough to have a look at what I've done on here. So these are the 4 resistors which limit the current from the inputs from the remote control chip, and these are the two smoothers for the current sense and the smoother for the supply, and these are just wired together, and these go to various Arduino ports. And if we look at this round and see if I can get it to focus, a bit more light, can we see those? Yes. Fortunately, the current sense pins are the two outside pins on the motor driver chip, and hopefully you can see I've chopped the pin and just hinged it up and connected a couple of wires over to the board, and that's that, all wired up. Just to mention this, I've also added a 12 volt power in so I can power it off my bench power supply in the initial stages, because it's got things like current limits in case I've done something wrong. And finally, I have built this little thing, which is a pretend one of those. So there are 4 switches for the 4 inputs. I only had 2 switches, there are 2 more on order, and there are 2 power resistors which are pretending to be motors, because I propose to power it up. Oh, and this is a 5 volts onto here just to put some voltage on those switches. So I propose initially to run it on the bench using this until I'm happy that it's all wired up and everything is working sensibly before we connect it up to the lorry. This is because I've only got 1 lorry, and if we blow that up, it's pretty much end of project. Whereas all this stuff I can replace. Okay, so let us firstly do some preparation work on the Arduino, and then we can connect it all up and power it up. Okay, the moment of truth. Let's power this up. So I have 12 volts input with the current limit set to about 40 milliamps for now, just for safety. So should we plug it in and see what happens? Ooh. So the voltage drops to about 5 volts and the current limit comes on. I don't think that should happen. Oh, hang on. The LED comes on the motor driver board. I am going to check using my meter what the resistance is across here. So, hang on. Come on. Well, 200 kiloohms again. Sorry, the meter's upside down. This is across the 12 volts. 6 kiloohms, so there's no short circuit. There's nothing connected to it. Yes, I've connected the power to the 12 volts, not the 5 volts. I've done it before, that would probably do for everything. The LED comes on. What happens if if I put the current up a bit, it's fine, okay. And the current is okay. Very little, maybe 50 milliamps, okay. Panic over, panic over. So I am going to check that there are no nasty voltages on any of the Arduino pins I've used. VDC. I don't really want to blow up my Arduino. Okay. And the analog lines at the other side. Oh, come on. Sorry. Don't know which one is which. A2. 1.1 volts. That is the supply as read by the A to D. So I will take that, and that one's nothing, and that one's nothing. And what's the voltage on there? 12 volts. Okay, so dare I risk plugging it in to the Arduino? Well, gotta do it sometime. No time like the present. So before we do that, I have set up the Arduino with a variant of the basic blink program, just so it's not doing anything but I know it's alive, and that's currently running off the USB. So I shall unplug that, I shall turn off the power supply, I shall plug them together. Are we in the right places? Yeah. This will plug the power in. And let's try and remember where the LED is so I can see it. Right, it's in there, hopefully. Be able to see it, and I shall turn the voltage right down and turn the power back on and bring the voltage up gently. The LED has come on the motor driver board, Unfortunately I can't see a thing that's happening. Oh, I can see something blinking under there. You're probably going to have to take my word for it. So the Arduino seems to be happy. Ah, there you go, next to the USB socket. LED blinking. So far it seems so good. Should we see if we can get it to do something? Okay, so here we have some Arduino code to test our hardware. So just a quick run through this. Set the pin modes, the inputs to input, the output. Now the analog reference is to internal, because that's 1.1 volts. Normally uses the 5 volt supply, which is dependent on the regulator on the Arduino board, which could be, I don't know, 5 or 10% out, and that's quite accurate. So that's 1.1 volts, so remember that. And we go into our loop, and our loop reads the 4 inputs and just sets the corresponding output to PWM 50%. So it just does something, basically. Press a button, you get an output. Okay, down here at the bottom we read the analog input. ISA is the current for A channel, ISB is the current for B channel. We measure the supply, we multiply the supply by 12. Now the ISA and ISB happen to come out at approximately milliamps, near enough for what we're doing here, and multiplying what comes out of the supply analog input by 12 gives that in approximately millivolts, near enough. And then we go down here and we print all this stuff out. Switch string is just a string which records the state of the switches, just so we know when the buttons are pressed. And we have a counter which is only used to turn the built-in LED on and off. The sanity check to check the Arduino is actually going round and in its loop, and delay 500 does all that every half a second. And that's that. You press a button, it turns the output on at 50%, just to check it's working. Okay, so I know that compiles. Will it do anything? Alright, we're ready to rock. Now connected up this test board. For some reason flashed then. Couldn't resist having a tinker around, so I put bidirectional LEDs on both channels so we can see what we're doing, and it's doing something, which it shouldn't be, I don't think. So should we fire our code down at it, hit go, and it's doing something, it's doing something, it's doing something. Okay, so if we, pointing the camera at the screen again, we reckon the supply looks like it's reading correctly. So if I, shaky cam, point you at that, turn the voltage down to somewhat below 10, yeah, 9.7, so we're happy that that's working. Okay, so if we go back to, it's flashing things on at random. Yeah, it's detecting switches at random. That's why. So if we look here, we're getting X's appearing in the left hand column where the switches are. I think that is because unless the switch is pressed, that input's actually floating. So I will shutter down and put some resistors of some sort just to ground those inputs when the buttons aren't pressed. Right, so I have modified this. You can see there's two resistors there. These are 10k and they're pulling the inputs to ground when the switches aren't pressed. This wire here, the shadow, is doing the job of the other two switches because they still haven't arrived. I've also fixed the 5 volts over there, which wasn't getting over to the switches. So we should be good to go. I'd also realised for these 3 entries in the switch string were all 0, so the first X was getting entered in here whichever switch you pressed. So I've fixed that, but what I haven't done is sent it to the Arduino, which I shall do now. Yeah, man. So that's done and that's going. So now if I press, put it around here, the first switch, yes, you can see that LED lights green. The second switch, that LED lights yellow. The third switch is that, the one nearer, lights green. Probably can't see because of the light. Yeah, and the one nearer lights yellow. So that's doing what we think. And if we look at the screen, okay, that's saying that's pressed and it's measuring about 50-60 milliamps. IA, press the second one, take my word for it please. Still measuring 50-60 milliamps on IA. The third one, no, it was, it's hard to, yeah, measuring 50-60 milliamps on IB. And the fourth one, again 50-60 milliamps on IB. So I think we are pretty much working, and we've gone on a bit for this video, so I think I'm gonna call it a day there for this video, and the next time we'll try and measure the PWM and possibly do a little more sophisticated input so we can change the PWM, and we'll get on to wiring the lorry up, and hopefully we can get some motors to turn. So for now I'm going to call it a day on this video, and if you like the channel, please subscribe, leave a comment if you have one, thumbs up would be nice. And for now, I'll see you next time. So it's goodbye from Triplicate, home of interesting electronics.